All right, on page 3 of Unit 1, Lesson 0, which of the graphs below represent a function? When you're just given a graph, all you can do is use the vertical line test. So if you take a vertical line and run it through, it's only going to hit it in one place. So this is a function. All right, same with this one. That's a function. Passes the vertical line test. This one does not. It hits it here and here and here and here. So that one's not a function, and that one's not a function. Okay. All right. These are functions, therefore we can have their domain and range. Up here, this didn't ask me that. This one's a little easier to do. When you get the specific, because they're all functions, okay? So what is this ordered pair right here? This dot right here is, you go over to 3 and then go up to 3. So that's 3, 3. This dot over here is -4, what? -1, okay? So if you need to write the domain of this function, it goes from down here, which is -4, right? And it goes all the way up to a +3 and stops. This is a line segment. When you have a dot on each end, it doesn't go on forever. See the arrow on these? These go on forever in those directions. These stop because it's a segment. It has dots on the end. So these get represented like this because there's an infinite number of dots like on that line all the way up there. So all the numbers in there count as the domain, all right? So we want to get that whole area covered, all right? And the range would be all the y's. So notice you're going, that's a y. So you're going all the way down to -1 and then all the way up to a 3, right? So that's the range. And then this one, what is this ordered pair here? This is all the way down at -2, -1. This right here, there's not a dot there, but it goes down. So that's at 0, -2. We should know that. And then this one here goes up to 2 and up to 3. Over to 2, up to 3. Okay? So the domain is, remember what the domain is, all the x's. This is the x-axis, that's the y-axis. So all the x's. So the lowest x is all the way down here at -2 x's, okay? And then it goes all the way this way. What is the farthest one this way? Right here at a +2, okay? And then the range, how far down does it go? Well, it goes down to -2. And then it goes all the way up to 3. So there's the range. All right, so you're kind of counting the x's from here to here, and the y's are kind of going from here to here. All right, so domain is x's, range is y's. Okay, and for this one, the arrows keep on going. So if they keep on going forever, okay, that means this will continually go this way. And down here, these will continually go that way. So the x's go on forever. They go on forever into the negative direction and into the positive direction. So that's the domain. How about the range of a line? This is line, right? Well, it's going up forever and it's going down forever. That way and that way, right? So that's its domain and range, okay, of a line. Hang on, I need to fix something on my paper. I apologize. Just a moment, please. making changes to the keys just to make everything as correct as I go along. All right, thank you. All right, last page, page 4. Lesson 0, evaluate functions written in function notation. Okay, we're back to that function notation. Another way to think of a function is a rule that is assigned to each, let's see, hang on, let me get my blue pen back. Another way to think of a function is a rule that assigns to each value of the independent variable. Rule that assigns a value, should be a value, to each of the independent variables. Okay, a function is kind of an input-output machine where an independent variable is the input and the dependent variable is the output. So that's independent is x and dependent is y. So instead of y equals, use function notation written that way, f of x. It's important to know that f of x does not mean f times x. It's merely a notation. Names the function with f, and then the parentheses we're given information about the variables that are in the function. So these are some typical letters of the names of functions. Okay. So in other words, this one right here is as a linear equation. Excuse me, it's not linear. It's got an x squared in it. As a quadratic equation, this would be a quadratic function. This is that quadratic equation in function notation. Okay, so notice that this is the f function. Okay, f of x equals these things, and then right here it says f of 5. So that's the same thing as saying what is y when x is 5. So you can put it in there. Step 1 would be proper substitution. Okay, I like to put the parentheses in. I think it helps. And then orders of operation comes into play. What do you have to do first? You must figure out your exponent first. So don't touch this. This is 25. And then if you want to, you can do this multiplication here because it doesn't affect anything else. But then you have to do this one here. So, and then you're ready to add. Two negatives add together to a bigger negative. All right, so a good way to write this final answer, if you want to, is f of 5 equals negative 95. That means when you put in 5 for the f function, you substitute the 5 in for all the x's, this is the sum that you get. Okay? All right, so what if you put in a 0? Let's write it out. All right, so exponents first. 0 times 0 is 0. 0 times negative 3 is 0. Okay, 0 times 4 is 0. So when f is 0, f of 0 is 0. Okay, that was a weird one. All right, how about a negative 3? So negative 3, and then, oops. So negative 3 times a negative 3 squared minus 4 times a negative 3. I like the parentheses. It helps a lot. Negative 3. What is negative 3 times negative 3, or negative 3 squared, is a positive 9. Okay. And then negative 4 times negative 3 is a positive 12. This is a negative 27. You add them together or subtract them, however you want to say that. A negative 27 plus a 12. This is where you get out your calculator if you need to. Negative 27 plus 12 is a negative. 27 is bigger. The final answer is going to be negative. Some people think about it that way. It's a negative 15. All right, now for something weird. We're putting a 2x everywhere there's an x. We are putting a 2x everywhere there's an x. Okay, that's what we substitute first. Then we square 2x. What is 2x squared? Well, 2 times 2 is 4. x times x is x squared, okay? Negative 4 times a positive 2 is a negative 8x, right? This here is negative 12x squared minus 8x. These are not like terms. That is my final expression there, okay? Apparently f of 2x equals negative 12x squared minus 8x. That is your final answer. They're allowed to look like that, okay? Now for the tricky one. Negative 3x plus 1 squared minus 4x minus 1. All right, squares first. Negative 3 times x plus 1, x plus 1. All right, minus, I can process all this. Distribute. This is going to be a negative 4x plus 4. A negative 4 times a negative 1 is a positive 4, right? This needs to be FOILed. First times first. Let's put this back. First times first is x squared. X times x is x squared, right? 1 plus 1 is that 2. All right, and then outside, inside, last. Let's add like terms here. That is negative 3x squared plus 2x plus 1. All this is coming down. All right, distribute. Negative 3x squared negative 6x minus 3 minus 4x plus 4. All right, can we combine anything? We've got an x squared here and an x squared there and a constant here and a constant there. So negative 3x squared minus 10x plus 1. Is that correct? I think so. I think there's an error on the key. Let me fix that real quick. Yep, there is. Excuse me for a moment. One moment, please. Negative 3 times 1 is a negative 3, and that plus that is a positive 1. Alrighty, moving on. All right, let k of a equal this absolute value. All right, so that's what it looks like for substituting 5 in for a. All right, so k of 5 equals 2, 5 plus 4 minus 3. Handle the absolute value bars first, because they're like parentheses. Absolute value of positive 9 is a positive 9. 2 is times a positive 9 minus 3. So I must do that first. All right, so we didn't touch that negative 3 all the way down. All right, and apparently k of 5 equals 15. Okay. All right, here's negative 7 here. So 2, negative 7 plus 4, negative 3, 2, negative 7 plus a positive 4 is a negative 3, negative 3. The absolute value of a negative 3 is a positive 3, so 2 times 3 minus 3. So this is 6 minus 3, so this is 3. No, wait, when k is negative 7. I mean, sorry, when a is negative 7. All right. What happens when it's 0? So 2, 0 plus 4, that's the same as 2 absolute value of positive 4, which is 4. So that's a 5. Oops, that's it for those. And the last one down here, it says write the equation of this line in function notation. Let's go with an f. and an x. So a line, remember y equal mx plus b. Well, instead of y equals, we're putting the fx, f of x. So I need the slope and the y-intercept. So where's the y-intercept? That's what I always start with, right here. That's the y-axis. Where does the line intercept the y-axis? Well, it intercepts it at what? 0, 1. All b's are always 0 something. Okay, 0b. So in this case, it's going to be a 1. So I know it's a positive 1. So I know that my b is a positive 1 on the end of the equation. So now I need a slope, because I'm going to be putting my x there, and I'm going to need what m is a slope. So how do you go from point to point would be the slope. Slope is the change in y over the change in x. Another way is rise over run. All right, so how do you go from point to point? Let's rise. 1, from this dot, go up 1, 2, 3, 4. So you're rising 4, and you're running back 1, 2, back 2. This is a negative slope. It goes down the mountain. Positive slopes go up, negative slopes go down, 0 slopes go across, undefined slopes go down. Straight, they're vertical lines. Okay, this is a negative slope, so this makes sense that you're going up and back. So up and back, and then we're going to reduce this fraction by 2, so you're going to get a 2 over a negative 1, which is a negative 2. So the slope is negative 2. In fact, you could put another dot here. See how you go up 1 and back 1? I mean up 2 and back 1, up 2 and back 1 for a whole number of dots on this line. So that's a negative 2 for a slope. So that is the equation of the line in functional notation. Thank you.